Okay. All right, so topic 22, comparing two samples, right? We're comparing two population means, right? So now instead of doing categorical variables and comparing proportions, we are going to do two quantitative variables and compare their means. All right, so we can answer a question such as this one right here. A survey found that the average hotel room in New Orleans is $88.42, and the average room rate in Phoenix is $80.61. Assume that the data were obtained from two random samples of 50 hotels each, and that the standard deviations were $5.62 and $4.83. The 1% significance level, can it be concluded that the average hotel room in New Orleans costs more than in Phoenix? So we have X bar 88.42 in New Orleans and X bar in Phoenix 80.61. And then standard deviation of New Orleans was 562. And standard deviation of Phoenix, $4.83. And our sample sizes were 50 for each. And that 50 is going to become important. What do you think is going to be the condition for a large enough sample size? 30. So 30 for each. So N is going to be 50 for each in this one. So our central limit theorem already applies. All right, so our hypotheses are exactly the same as we were looking for when we were comparing two proportions. But now instead of using pi for our population proportion, we're talking about mu. Right? I prefer that the alternative hypothesis test is written like this when we're comparing two means. However, it is equivalent to say that their difference is either not equal to 0, greater than 0, or less than 0, right? By just subtracting that over. Right? So our null and alternative hypotheses are identical to what we've been looking at before. We have three choices. Remember, the null hypothesis is that it's equal to, or the two are equal possibly. Right? And then we're going to compute that p-value, assuming the null hypothesis is true. And remember what that p-value is. The p-value is small enough, right? Less than our significance level, which in this case is a 1% significance level. Then we're going to go ahead and reject our null hypothesis and say that there's enough evidence to say that the alternative hypothesis must be true. Right? Remember what that p-value is. It is the probability if the two population means are equal, the probability we can get two sample means that different if they are equal. And if that probability is very small, we're going to reject the null hypothesis that they're equal and assume that the difference could not be attributed by chance alone. Therefore, the population means must in fact be different. So in the context of this one, let's go ahead and lay this out. Of course, we're going to always start by identifying our procedure. This is a two-sample t-test for population means. There's two sample t-tests for population means. Right. So we've identified our procedure. We want to compare population means. Right? And these are independent samples. And we'll look at it like this. Right? So our null and alternative hypothesis. Null hypothesis. Mu New Orleans equals mu of Phoenix. And our alternative hypothesis, we want to see if there's a difference between the two cities. So we're going to just go ahead and test that the mean of New Orleans is not equal to the mean of Phoenix. And we have a significance level of 1%. And let's go ahead and identify our parameters of interest. So, mean New Orleans, right? The true mean cost of hotel rooms in New Orleans. And you mean Phoenix, same, but for Phoenix. Our first step is all done. Okay. Identify our procedure, identify the null and alternative hypotheses, identify our parameters of interest, and state our significance level. Anyone have any wild guess what our second step is going to be? Verify conditions. Very good. All right, so let's verify our conditions, right? And these conditions are going to be quite similar to all the other ones, right? We have our simple random sample, and we want them to be independent samples. We'll look at a procedure for dependent samples and where it's appropriate to use that in the next topic. But these ones are for independent samples, right? And then remember the same applies for our central limit theorem. The distribution is approximately normal in the population, or the graphs of both data sets show no reason to suspect a lack of normality, or both data sets are larger than 30, right? So it has to apply to both. So if we have data sets that are smaller than 30, again, we're going to look at dot plots, histograms, stem plots, any sort of graph we'll display in order to establish normality in the population. Remember, our data should mirror the population shape. Okay? So in this one, right, let's verify our conditions. So conditions for our sample problem. 1, SRS for both. And always state for both when we're checking these, and that was stated in problem. 2, no reason to suspect a lack of independence. And 3, and 1, and 2 greater than or equal to 30, and 1 equals and 2 both equals 50. There's no requirement that says that they have to be the same size. It just happened to in this particular example, right? You could have one sample of 35 or one sample of 45. It wouldn't make any difference. On step 3, we want to go ahead and calculate our test statistic and our p-value. So our test statistic here, and we calculate our p-value using either the t-table, t-CDF, or we use the normal CDF if we're given the population standard deviation. This is where we have one additional step, right? So remember, when we were discussing means, we had the z-test or the t-test we can choose from. We would choose the z-test to compare population means if we know both population standard deviations. Right? So if I know both population standard deviations, then I'm going to use a z-test to compare those. And this will be a z-test statistic, and we can use normal CDF. If I'm using the standard deviations from the sample, right, we're going to use the t-distribution because those same faults still apply when we're using the standard deviation from the sample. So we're going to largely rely on our calculator. This can get a little bit messy to go ahead and calculate that test statistic and p-value. Okay? We're going to investigate this as we go through the classwork today to see how the standard error of our distribution and how the confidence interval interacts. All right, so let's go ahead and get out our calculators. And let's go ahead and calculate our test statistic and our p-value. I don't know if this will work on the recording, but we'll go ahead and give it a whirl and see if it still is recording. So, on our TIs, we're going to go into the stat program and then go over to tests. And this is a 2-sample t-test. So a 2-sample t-test. And I'm going to type in stats. So X bar 1, my New Orleans, 88.42. Standard deviation, 5.62. N1 is 50. And then the standard deviation, or the mean of Phoenix, is 80.61. And the standard deviation for Phoenix is 4.83. N2 is also 50. And then we want not equal to. And it's important that we do this. We're never going to do pooled. It's always going to be no for pooled for right now. Pooled is only for the circumstance in which we're making the assumption that both parent populations have identical standard deviations, which is not a really appropriate assumption to make in almost all cases. So for this class, we're going to always do not. Okay. Calculate, and there's our test statistic and our p-value. Okay, so let's go ahead and report those, and then we can go ahead and make our conclusions. Let's go back here, make sure it's still recording. And we are still going. So our test statistic. We have T equals 7.45. And we had our p-value of approximately 0. And since 0 is less than 0.01, we're going to reject H naught. We're going to reject H naught. So we have significant evidence that there is a difference in the two population means. And our last step, as the same, if our p-value is less than our significance level, we reject, and we state our conclusion in context. So at the 1% significance level, there is sufficient evidence to say that there is a difference in the true mean cost of hotel rooms in New Orleans and Phoenix per night. And the next part, right, is we want to calculate the magnitude of that difference. Okay? In order to calculate the magnitude of the difference, we are going to go ahead and do a confidence interval. So our confidence interval for a 2-sample t interval is the difference between the two population means. So we want to calculate the difference between the two population means. Here's the formula for the interval. and the technical conditions are identical. So we're going to also use our calculator to calculate these intervals. So how we set this up, the first thing, this is a 2-sample t interval for population means. Our conditions, same as before. And then let's report our interval. All right. So our interval, we run that in our calculator. That's going to be a 2-sample t interval. Go back over to here. So again, I'm going to go into stats, over to tests, and I'm going to keep going down. So this is a 2-sample t interval, the 0 one. It should pull everything in for us, which is nice. Remember, you typically do both the hypothesis test and the associated confidence interval together. All right, let's do a 95% interval. We aren't given any. Let's calculate that. And we're given the interval 5.73 to 9.89. Right, so let's report that interval. And our interval, 5.73 to 9.89. And this gives us the magnitude of the difference between the two population means. So I am 95% confident that the difference between the true mean cost of a nightly hotel room between New Orleans and Phoenix is between $5.73 and $9.89. The other way to go ahead and interpret that would be to say that I'm 95% confident that New Orleans, the true mean cost of a hotel room in New Orleans is between $5.73 and $9.89 higher than the true mean cost of a hotel room in Phoenix. Now we'll get going on that class, right?